might get crossed. Alright, them say we must find angle. Oh, there was some reading. There was some reading in it too. Yeah. They say the diagram below, O is the center of the circle, A and B are points on the circumference. So, and they say angle A is 29. So which rule this would be? It would be angle in a semicircle equal to 90 degrees. So right here is 90. This is the key to it. And then now we can focus on angles in a triangle. Now angles in a triangle sum to 180 degrees. So it would be 29 plus 90. 9 and 2, that are 11. So all we need to do now is subtract. We need one more to make 20, right? So that would be 61 degrees. Or we could say since this is 90, this plus this equal 90 degrees, right? Those are complementary. So that would be 29 plus x equal 90. So we could have subtracted from 90 degrees as well. We will still get the same result. So 61 degrees. And of course, you have to put your hand the reason. So they have two reasons. Angle in a semicircle, that's one. Angles in a triangle sum to 180 degrees. So make sure we have them, those reasons, guys. Angle in triangle sum 180. And then angle in semicircle. So please write down the reason, because you know CX is already. They love the reason now. So please ensure so you put that. CX would have given probably 2 marks for this because they're gonna ask for the reason. CX love to ask what's the reason. All right, let's move on to the next one. Very important, guys, very important. This one says A, B, and C are 3 points on the circumference of another circle. O is the center. Angle AOB is 112. Work out the size of angle ACB. All right, so it's A, B, and C are 3 points on the circumference of a circle. O is the center. So they told us that O is the center. That's very important, you know, because the 112, this 112 here would be the angle at the center. We remember what the rule say. The angle at the circumference is what? So let me see. That's our ACB.
So it's half the angle of the center.
Yeah, that is it. So all we have to do is just divide it by 2 and we give the reason. Remember, in a 2 you can write it. Angle at circumference is half angle at center. Please write down the reason, guys. Some people just give me the 50 alone, you know. Write the reason, guys. Just get in the habit of writing it because CXC want you to write it. Or we could say the angle at the center is twice angle at circumference. We got Mr. Mitchell for that device, but you know, my writing that, you know, guys. See, remember one time I struggle? Yeah, I can write fast on them something. So yeah, all we have to do divide that by 2 And as we say, it'll get what? 2 into 11, that's 5, remainder 1. So 2 into 12, 6. So this would have been 56 degrees. But the answer is not complete for CXC without the reason. The angle at the circumference is half the angle at the center, or the angle at the center is twice. So just remember, the angle at the center go bigger, right? It go more open. So make a note of those and make we share it down. All right. Another one. It says A, B, C, and D are points on the circumference of the circle. Find the size of angle DAB.
Mr. Benedict, can you bring it back down? Let me take the picture, please, sir.
As in go back up to it though?
Yeah.
Okay. Sorry guys, sorry.
You can proceed, thanks.
All right, thanks so much. Anybody else want it? All right, yeah. So let's say find DAB. So just like what I did with the Monday class, guys, I'm gonna add in one more. All right. So then ask with DAB, we're gonna find the two of them just to practice. So they ask with DAB, which is this. So I'm gonna add in, find this one as well, just for
But,
practice.
but if I scroll down on the paper, it is there, sir.
Oh yeah. All right, let me see if I can small it. So they ask with both of them. So I find it up here, so guys. Oh no, well, that's scroll down. All right, let's go, let's go. All right, so it's A, B, and C. A, B, C, and D are points on the circumference of the circle. So as we discussed, that makes it a cyclic quadrilateral. So two things will make it a cyclic quadrilateral. One, it has to be a four-sided figure. So we can count them and we see that, yeah, 1, 2, 3, 4. The next thing now, the vertex must sit on the circumference. So all four must sit on the circumference. So for those who are not here, this is what we call a cyclic quadrilateral.
Question, Mr. Bennett. If it does not sit, that means that it's not a cyclic?
Correct. It must sit on the circumference. All right. And it have to have four sides as well. All right. And the thing about cyclic quadrilateral, the opposite sides are supplementary, meaning they add up to 180. So like this 62, this plus angle A must add up to 180 degrees. And the one with 95, so opposite, right? Opposite I want to face it. So you can just draw one line and you see the one that is opposite to it. All right, so I'm going to find them. They said DAB, so it should have been 62 plus DAB equal 180. And then we can transpose, right? Angle DAB equal to 180 minus the 62. So 2 from 8, that leaves 6. 6 from 17, 11. That's what you guys got? Not 8 for the answer. You know what I mean? Oh. Yeah, so it should have been 118. And this is for this one here. One with 62. DAB. All right, let's find ABC. So ABC is opposite to this one, ADC. So it's, what else was it? 180 minus 95. 5 from that leave 5, 9 from 70, 8. So that's 85 degrees. So this one would have been 85 and this our 118. But all four angles will add up to 360 degrees, right? And the reason would be opposite angles in a cyclic add up to 180 degrees. And both of them would have the same reason. And why this, you know? For those who are not here, I'm gonna try and remember to post the somebody just called me about it and say, sir, you never send the rules to the persons who are absent. These days guys may have marathon and a whole heap of pressure, but I'm gonna try and remember and post it. Because the rules are basically what we need for these. And then once we know the rule and it bundle, we can figure it out same way. All right. Let me know if we can proceed to the next one. Pause the video. Come on about the empty space. All right. So I have something to say about this, guys. It's a circle with center O has points A, B, and C on the circumference. So they are all on the circumference, right? And there's an angle ABC. So we know if we identify angle, the one in the middle. So A, B, C is 20. So this one is 20 degrees. So we can actually put it here, right? But remember, this is in a semicircle. So that means this angle would have been 90 degrees. So bear in mind, this is 90 degrees. Very important, right? So that means we know, once we know any two angles in a triangle, we can always know the third one, right? Because the 90 plus this will give us what? 110. So that means whatever add up to 110 would give you the third angle. So it would be 180 minus 110. So it would have been 70 degrees. So this angle here is 70 degrees. I think I can make this a little bigger, you know. Just in case somebody have a phone, it show bigger. So that would have been 20. Remember, you know, guys, that angles of a triangle, the interior angles of any given triangle, the sum would add up to 180. So once we know that this one is 90, it should be very easy for us. Once we know that this is 90 degrees and this is 20, we know that this plus this would give you the 90. Because all triangles sum to 180 degrees. Doesn't matter if it's equilateral, scalene, isosceles, right? All angles in a triangle add up to 180. And bear in mind, this is one of the rules, angle in a semicircle, sum to 180 degrees, sum to 90. I may use add. And then angles in a triangle, sum to 180 degrees. So is that gonna twist up there? So bear in mind, guys, please remember CXC want you to put the reason. They're gonna say give reason. So That should become a part of it. Sometimes I'm in class and students will just give the calculation and then I say, what's the reason? And they hesitate. So make the reason be a part of it, guys. Please. Alright?